Hello, eCognition and YellowScan fans. We are just sneaking in our monthly webinar here for April, last day of the month. We have an interesting talk today. Myself, Keith Peterson, I am the product manager for our Trimble eCognition software, and my guest, Cliff Holle from YellowScan, will be presenting the very interesting topic here, looking at the future of vegetation analysis mapping in feeder corridors with Trimble eCognition, boosted by wonderful YellowScan LiDAR data. And we have some good stuff to cover here. I'm going to give a brief introduction to eCognition to begin with. And then we'll look at the current status of vegetation encroachment analysis out there on the market. And then we'll get an introduction to YellowScan for anybody who's out there that's unfamiliar with YellowScan. This is a good chance. Cliff can cover all the ins and outs of YellowScan and UAV-based LiDAR, a really cool technology that's been becoming more popular over the last several years. Then we're going to take a look at several projects. First, we're going to start out with the real topic here is risky tree detection, looking at how we can automate the detection of these various trees using purely point cloud information and what type of deliverables we get from that. And then, like I said in the webinar description, we took the opportunity here to really try and push the envelope with eCognition. What can we do with our great point cloud feature extraction tools? And we're going to take a look at some call it a pilot project that we've been working on internally. I don't want to say any more now because I don't want to spoil it. So we'll take a look at some of this 3D line extraction work we've been doing, and then we'll finish off with some questions and answers. Just before we jump into the webinar though, let's cover some of the rules. Yes, everybody's on listen only mode, so it's correct that your mics are turned off. I hope you can hear me fine and that all the audio and presentation is going well. If you have questions during the webinar, please submit these in the question field. We will be taking some breaks throughout the webinar to ask questions here or there, so feel free to fire those off right away when something comes up. And also, if for whatever reason you have to exit the webinar early, you get distracted, you miss something, don't worry, the webinar is going to be recorded. It will be available in the Trimble Geospatial webinar archive, as well as our eCognition TV YouTube channel afterwards, and you can go and rewatch the material that we've covered here over and over again. So that being said, we'll jump right into our topic today. I'm going to start with an introduction to the Trimble eCognition. So we have maybe some folks out there that are YellowScan users or UAV LiDAR users in general that maybe not be familiar with the concept of eCognition. So let's take a look at the idea of Trimble eCognition. First of all, what we are all about is transforming our geospatial data into geospatial information. So we're taking these representations of the real world that come in, say, image data, for example, on a raster, or elevation data, whether it's going to be a point cloud or rasterized, whether the point cloud's coming from LiDAR, whether it's coming from, say, a photogrammetric source. We can incorporate these wonderful data sets and create information from them. Traditionally, though, this has been a manual process. So we go into our let's say our area photos, we're looking for forested area, we go in, we digitize these areas, see it in the photo, but it's required a manual operator, an expert to go in and actually do the information extraction, the change detection, or even object recognition. Where eCognition comes in is then to sort of take over the manual step and now automate these steps that we were once taking to create then land cover maps, impervious surface maps, maybe even looking at individual trees, so extracting those individual objects. And that is the real art form of becoming an eCognition rule set developer, is to automate this, and we're going to show some of this in our demonstration today. Again, Trimble eCognition for mapping. Where does the eCognition software fall into this this workflow? So we're transforming our raw data from satellite, aerial, or drone sensor, and we're really turning this into rich geospatial information. But where does all this happen during the lifespan of your project or your data? And we obviously have the collection from various sensor types. We have what we call pre-processing or processing step. This is where we take the raw material. We're creating orthophotos, image mosaics, point clouds, elevation models. So whether that happens in software like the Trimble Info Package or Trimble Business Center, there are a number of options for getting this data processed and ready then for eCognition. Where we come in is then the analysis and the information extraction. And then finally, what happens to this information that we're generating is that we create then the input for, say, various GIS softwares that are out there. So we're taking the data and we're creating the information that is then used in or elsewhere. That being said, we're going to get to the topic of vegetation analysis in feeder corridors. It's the story that we're looking at today, if you will. And how this, the problem itself is, I think last year in the Munich, Germany area, we had a very severe winter. We saw a lot of these problems happening all over southern Germany and into Austria with severe snow and storms going on. We have trees, various other encroaching vegetation coming into corridors. And when that's combined with wind, storms, snow, any type of these types of events, we get interruptions in, say, the electric network. But we can also on just an electric corridor. We also have situations in gas pipelines, rail corridors, road corridors. Any of these types of corridor setups will need to monitor what type of encroachment is coming into that, whether it's going to be vegetation or some type of other object. How is this currently being done? Well, we have terrestrial inspection. We're sending out people with hardware devices to take notes, GPS locations, with boots on the ground. We also have aerial inspections. Maybe it's a helicopter or another type of flight where a professional is up there and doing the actual monitoring. And then you have also pre-existing point cloud classifications, these based on manual interpretation. And the problem is all three of these it's manual work, so it's cost intensive and time consuming. Also, we're relying on the various expert opinions to do this work. So there's less standardization as there maybe should be. Where are we taking this in the future? So just looking at the future vegetation analysis in these feeder corridors, we have a lot of new or emerging technologies that are allowing us to collect more data at more affordable prices. And one of these is obviously UAVs. So this enables us to collect data in a wonderful, high quality, and this allows us to better automate the entire analysis process. So what do we need? Well, we're taking input information. So we start out with the power line corridor itself. This could be a shape file, so a vector file. We can combine that then with the data collection. Could be a combination of images and point clouds, whether it's going to be LiDAR or photogrammetric point clouds. Again, eCognition can handle these files as long as they're in LAS or LAZ formats. The images, as we'll see in the projects that I'm going to demonstrate today, I'm not actually working with imagery, so the images become optional in the workflow that I've chosen. We're basing this solely on the point cloud data itself. And of course, we want this output, our analysis output, this is going to be when we want to identify risky trees or parts of the canopy that need to be removed, addressed in some manner by the operator. So that is a quick introduction to eCognition and the problem at hand that we're going to look at today. Like I said, we've have just partnered with YellowScan for this webinar. It gave us a great chance to test out some of the stuff we've been working on with UAV-based LiDAR systems. And I'd just like to introduce my guest speaker quickly here. I think he can do himself more justice. It's Cliff Holle. I've known Cliff for ever since I've been with Trimble. It's been a great work that we've had together. He's had over 25 years of geospatial information experience with all sorts of cool projects within the industry, from GIS database development, looking at remote sensing techniques, and LiDAR and photogrammetric services. And now he's working at YellowScan as their GM and business development. And Cliff, I know has some slides to just introduce for those of you maybe coming from the eCognition background, not familiar with YellowScan technology. Cliff, I'm going to hand over the reins of the presentation to you, and you can tell us about YellowScan.
Yeah, fantastic. Thank you. Let me. All right. Can you see that okay there?
I can see your screen fine, Cliff. So
perfect. Well, thank you very much, and welcome to everyone there. I know you're coming in from a lot of different locations, so I'll bypass the good mornings and good afternoons and just say hello. I do appreciate the opportunity. As Keith mentioned, we've known each other for a while. I've known the eCognition product for a while and have been, very directly and indirectly involved and enamored with the product. And as you would imagine, of course, with any data production process, it all starts with the input. On the first day there was data, so to speak, and that's kind of the part of the process that YellowScan comes into this with. The better it refines the data, the better understood and characterized the data, the better the workflow can be automated, and ultimately the results can be shown to be, relevant and useful. What I want to do is just show just a quick summary here, a little bit about YellowScan, nothing too heavy. For those that are new to LiDAR, just a couple of slides about what we're talking about, and then a brief overview of just a few of our UAS LiDAR products, how those products provide the unique mapping capabilities, and then just the general workflow of how you would bring that data through the hardware, through our software system, and then to the point where eCognition, and in this case Keith, would take over and utilize those data. So about YellowScan, we've been manufacturing LiDAR for UAV since about 2012. But we come from a longer heritage. Our sister company, L'Avion Jaune, which is a French company in the south of France, has been doing geospatial service projects for many years, and have a variety of academics and commercially oriented folks doing all types of aerial acquisitions and providing data results out of that data. But they quickly came to recognize in their manned acquisitions that they had a real need for a small, lightweight, not so power-hungry LiDAR system that could be flown in the environments where a manned aircraft either just couldn't be justified for cost or needed to be reflown on such a regular occasion that having the regionalized asset was a bigger requirement. And so we, hence developed the first concept of a YellowScan LiDAR. The company became known in France as YellowScan, and then throughout the last few years, and then most recently this year, 2018, we opened the second office. This one now being here in the United States, in Salt Lake City. So we have a YellowScan Inc. operating here in Utah, focused on the sales and support of our customers in the Americas, both north, south, and central. Let me back that up for just 1 second, actually. What I didn't mention here is that all of our systems have included in them a Trimble or a Planix APX series board that ties us even closer to the Trimble family. It's not just the hardware that's in our systems that makes us part of the family, but also the fact that by using these APX series boards, we are also able to use the Trimble satellite-based correction service, or the PP, the post-processing RTX feed, which would allow you also then to choose whether you correct your data with localized base station, cores, if you happen to be in the vicinity of a core station network, or in this case, being able to do a post-processing through this RTX feed. So it really is a liberating technology to not have to drag another piece of gear in the field. As I mentioned earlier, 2 offices, headquarters in the south of France in Montpellier, and our newest office in Salt Lake City. And actually, I guess I have to back that up. We actually have an even newest office in Japan. We've just announced the joint venture in Japan, and so we will have a YellowScan Japan office opening in the very near term. So as I mentioned, we've got many years of experience in the field flying both fixed wing, rotary, multi-rotor, manned and unmanned, constantly looking for high quality products and services to deliver to this group that was involved in services for all this time. And in the background of all of this, software development, a combined 100 years of software development experience that we're now bringing into the side of YellowScan for not only the initial pre-processing, but also doing an appropriate amount of post-processing support to make the tool as useful in the field as is reasonable. So just very quickly, what is LiDAR for those that aren't directly involved in it already? Light detection and ranging is the acronym. So LiDAR is really just, if you're familiar with radar or the concepts of sonar, it's simply sending out, in this case, a laser-based signal rather than some sort of sound or acoustics, and using the speed of light and timing circuitry to basically determine the distance or range that each of those laser shots takes before it hits a surface, reflective surface, and comes back to the receiver. That's the primary concept. So you have an emission and then some number of echoes, and then ultimately the reception of those echoes back up to the receiver. The multi-echo technology is one of the core, I guess, capabilities that really differentiates LiDAR technology from some of the, I guess, more passive sensing like camera-based systems, in that you can receive more than one echo or more than one return for a given LiDAR pulse. And what that allows for then, of course, is for one single laser pulse to be able to look at multiple surfaces, whether that's the top and the bottom of a fence or wall, penetrating through various parts of the structure of canopy, and ultimately, in most cases, trying to get down to the ground to discern modeling capabilities underneath the surface of the canopy of the trees. The laser beam, how that works, obviously it's not just a straight line. Obviously the light diverges as it exits the system down to the ground, and that divergence and that spread of the beam somewhat allows for multiple surfaces. So only a portion of the beam is interfered with, if you will, on the first topic or the first return here at this level, the rest of the beam going down to the next, and then of course the next and the next. So depending on the complexity of the LiDAR system that you're using, many different echoes can then ultimately be discretely discerned and measured. So what's in a YellowScan LiDAR? And I would go so far as to say that the basic components shown here are really in most any LiDAR system. How we configure ours, the choices of subsystems, and the way that we integrate all those subsystems makes us unique in our sense. But basically you have the three components: a laser scanner. This is the device that's going to be doing the distance measurement. It's going to emit the laser pulses and record the travel time for the echoes that particular system is capable of keeping track of. It's also going to measure the scan angle for those particular laser shots that are being sent, so that you know where those points are hitting the ground. Of course, then you have the navigation and positioning systems. This again is the Trimble product, the APX15 and the APX20 are the two products that we're currently using in our LiDAR systems. Using those to determine the absolute position. This is the GNSS side of the boards, as well as the orientation, which is the IMU, or the initial mapping unit of the sensor. So the pitch, roll, and yaw of the aircraft. So then you know exactly where that LiDAR is pointing as it shoots its laser. And then finally, the onboard computing technology. This is the computational portion that's required to define the precise echo positions, and is required for the on-flight data visualization when you're using that functionality as well. Our systems also incorporate, because we are sort of a fully standalone system, we have our own power source built in. It's a removable interchangeable battery. We also have the onboard data storage. So in reality, these systems are really just in need of a platform to carry it with an appropriate vibration isolation to ensure that the LiDAR is operating at optimum capabilities. So in its full system, then again, of course, you have this GNSS correction system, whether that's your local base station, core station, or as I mentioned, the RTX feed coming from Trimble to those Planix boards. The entire system then becomes known to where it is, where it's pointing, the timing and everything. And at that point, then you can create your point cloud with known coordinates of a known accuracy and quality. These are the fully integrated sensor systems that we offer. Our initial product in the beginning was our YellowScan Mapper, which has now moved into Mapper 2 model. The Surveyor is we have two models using the Velodyne products. The VLP16 is our Surveyor, so it's a 16 laser system. I'll tell you a little bit more about the specs on these in a moment. We have the Ultra, which is the Velodyne VLP32, or the Puck Ultra. And then we have a series that we call our VX series, the 15 and 20, which are both using the Regal Minivux laser head, and then either the Planix 15 or the Planix 20, APX20 on those systems. Then, and lastly, of course, we have the newest of that series, which is our VX20DL, which is the downward looking. So in this particular instance, it's still the Regal Minivux, but it's the downward looking, or DL version. A special filtering, circular filtering, takes the entirety of the 100,000 pulses per second that would normally be spinning 360 degrees around the device, and concentrates them in a circular pattern directly downward into a 46-degree field of view. Very, very much targeted towards the corridor type mapping exercises. Just to kind of give you a very brief comparison of the different systems, 4 laser beams versus the 16, 32, and the 1. the number of echoes. You have 3 standard Velodynes right now are 2 echoes. The Regal-based systems in the VX series, a maximum of 5 echoes. And so you can see also then the density of the data being collected from 18,500 to as much as 600,000 echoes per, shots, laser shots per second, and then 100,000 for the single laser of the VX. I'll just kind of go through this a little bit quickly so we can jump into the use of the data. But what makes LiDARs and UAV situations make sense is the scale. Oftentimes, now that's obviously changing as the LiDAR systems become smaller and more powerful, as the UAV platforms become more powerful and capable to fly longer durations, as government agencies become more adept at figuring out how to let these systems fly in mixed airspace. We're starting to see that what makes sense economically for these platforms is shifting. But suffice to say that a mapping system with a VTOL, some type of a fixed wing vertical takeoff and landing, easily 30 kilometers in a session, 400 hectares in a session, wouldn't be anywhere near unreasonable. Smaller areas, if you've got a multi-rotor, any of the multi-rotors out there, again, 10 to 100 hectares is a pretty good sweet spot. Although we've certainly had people flying much larger areas with those multi-rotors as well. Of course, any kind of mapping under vegetation, hard to access areas. These are not just human on the ground, hard to access, but oftentimes it's hard to access financially by getting the mobilization costs for manned aircraft to come in and do certain things. The fact that we can fly much lower than even manned helicopters typically, just due to the size and scale, also gives us a data density and an accuracy that at times can even be better than some of those platforms as well. And of course, accuracy is a scale, depends on what you need. Every tool has its job, every job has a requirement. So we have a variety of tools that can provide accuracy somewhere in the 2.5 to 10 centimeter range. And I choose not to do a comparison of say photogrammetry versus LiDAR. I think in our opinion, the two technologies are very complementary to one another, but there are some strengths and weaknesses that each can bring to the table. Now, in our situation, we fly both sensor types concurrently. As I'll show you in a moment, the data that came to Keith for this exercise today was from our VX20, also carrying dual Sony RGB cameras. And so obviously taking the benefits of both and maximizing the utilization of a single flight is what many of our end users are currently interested in. But as far as LiDAR is concerned, being able to penetrate vegetation, I say any weather, obviously there's limitations, but photogrammetry is going to have a real hard time in fog. We can get through some of that much more easily. The high contrasts, anyone that's done photogrammetry and trying to do image balancing knows that the high contrast areas are often a problem. Obviously, that's not an issue with LiDAR because of the active laser nature of the data acquisition. Low sun angles, dark, dusk, as long as you're allowed to fly in your region in those time frames, we don't need the light of the sun to obviously get out and collect data. But believe it or not, obviously a lot of our LiDAR systems are based on lasers that would actually be absorbed by water. But when snow is of a dry water content or moisture content, we can actually do quite a lot in the area of texture analysis, height of snow. So we're seeing more and more interest in some of our end users looking at doing snow measurements and things of that nature with LiDAR as well. So the workflow basically starts out with the acquisition. And as I mentioned earlier, this is the system that was flown. This was a DJI Matrice 600 being flown with the VX20 and a dual stereo-looking pair of Sony Alpha 6000 cameras. The whole concept between the whole concept of our product line is to try to make LiDAR acquisition as reasonably accessible to the average person out in the field. You know, LiDAR is a complex technology. LiDAR processing can be a complex process. It doesn't have to always necessarily be that complex, and so our concept of just press the yellow button is our attempt to take the technology into the field, be useful and successful, but without having to have the proverbial LiDAR engineer traveling along with the flight crew in order to collect good data. And of course, just a nice aerial shot of the system being flown. And I believe they're getting about 20 minutes on the larger, I forget the model number, but the DJI's got a larger model number on the battery, and they're getting about 20 minutes with a very safe margin left per flight. So LiDAR workflow, and I think this is the last of my stuff here, is really just about the initial Juniper. By the way, Juniper Unmanned is one of our partners. They're the folks that provided us the data being used for today. Just wanted to give them a very appreciative shout out and thanks for sharing this data. And then from there, of course, we take the data, the base station, PPK, the raw trajectory data into Planex's PAWSPAC software, where we do a trajectory correction. Added to that, the raw data from the scanner and the IMU data. This is the pitch, roll, and yaw angles into our cloud station software, and combine those products to get a calibrated LAS point cloud, which at that point is available for use in one of many different workflows. In this case, directly digestible by the eCognition software. And I believe that is all I have. I think you've got this information available to you, but for those that would like to reach out with additional questions, I'm very happy to help out later on offline. I'm going to transfer this back over to you, and
Great, thank you, Cliff. As you can see, I've already got some stuff loaded in eCognition, but before we get too far, I just have a few more slides to show here. Get out of my notes mode. Should be able to see my PowerPoint again. If there were some questions that came up on YellowScan, please hold on. We'll get to some question and answer at the end, but I think we're excited to get into this automated solution with the UAV-based LiDAR. Just to give a quick overview, what are we really doing here? Step one, we're looking at automated point cloud classification. So we're getting, if you will, sort of a naked point cloud. It comes in, there's no classifications. And what we're going to do is we're going to give it some classifications here. We're going to automatically classify ground, vegetation, buildings, and power lines. Buildings if they're there, and the other things as well. And then it's important to look at what type of, how are we assessing this risk? And there are some industry standards. So of course we have this power line. We have a little diagram here of all these different these zones and things we need to consider. So first of all, we have this proactive fault clearance here in the diagram, what this is, and this is also going to be a parameter that you'll see very shortly in eCognition that we use. These are user-defined parameters that they can use in the form and our rule set. We have these stored as variables. So there are 4 important user parameters. The next one is branch removal zone. And then we also have that's described in our rule set as this min below distance. We then have what we call the feeder or the underlying vegetation. This is going to be influenced by the feeder corridor width parameter within eCognition. And then we also have vegetation, neighboring forest. there's obviously going to be trees that might be outside of the actual physical right-of-way or the corridor that are still high enough to pose a threat in falling on or touching the power line. And so these are also things we want to identify automatically. And we have obviously formulas that we can use to calculate these distances, and the crossing offset being the last parameter that we use within our rule set. And so this is the background. Keep this slide sort of in the back of your head when we get into eCognition, because you'll see these parameters as seeing variables that are then used. Remind myself to point them out to you when we talk about them. But these are what we're going to use then is essentially to form our class descriptions. Then we look at this automated risk classification. So we're taking these parameters, like I said, and then we apply them within a classification, a class description, and we actually classify the point cloud and create some 3D vectors from that as well. Those will then form the basis for our deliverables, as you see here. So again, classifying the point cloud, just looking at it from a slightly different angle here. We have the various risk classes, if you will, along the corridor, within the corridor, and the deliverables that we want as output a classified point cloud. That's wonderful. But oftentimes the classified point cloud itself is, what do I do with it? It's not the most useful deliverable that you might have. So we also can deliver vector files that correspond to the crowns and trees that need to be examined. And we can do this in 3D, of course. So that being said, how does it all work? Let's jump right into eCognition now. I will get out of the PowerPoint, and you should see my eCognition screen. I see there are a few question flags up. Michael, before I jump into the rule set and explaining how this works with this LiDAR data, do we have any questions that should be answered? Any burning concerns?
We do have some on YellowScan, but do you want to take those now or wait till the end?
I think we can gather those and wait for the end when we do a bit of a recap. But let's just jump right into the rule set, okay. and then we'll come back to questions with YellowScan. So we'll try and get you at the end. So Cliff mentioned they flew not only with the LiDAR, well, they flew the LiDAR device, obviously, but they were also collecting RGB. So no, this isn't a wonderful aerial image. This is actually what the RGB view of the point cloud looks like within eCognition. So I can see here in my view settings dialog off on my left-hand side that I'm looking at a point cloud. We've just named this point cloud LiDAR for lack of creativity. And we have various modi that we can select when we display this point cloud. So I'm currently in the RGB mode. I can also look at this, say, in its default mode, and that's looking at it based on height. We have this corridor here. If you cannot see it, I'll turn on some vector lines. These are the red lines here, and so a digitized power line just running down the center of these power lines that we see here. I'm trying to zoom in and show some of the detail that we get from this and the environment that we're dealing with. So we're rendering this point cloud here. I'll turn off those vector lines. And we can see that we do have some lines here. We can also adjust our point size here as well. I get a better sense of what's going on here. So what I've done initially in this rule set, it's broken up into three parts, we could say. The first part is what we call sort of a pre-processing. I've run this in advance because, as you can see, this is a little slower. This is where there's a lot of data computation going on, and it took around 30 minutes to run here this morning. So I've run this ahead of time. We don't have to sit here in the session and let this turn. But what exactly was I doing here? Well, first of all, I was looking at calculating a right-of-way, and the way we've created this really production-oriented rule set is with some very nice, savvy options. First of all, you may see, anybody familiar with eCognition might see that we have these simple callouts here, these parent processes called then, else. What's going on here? Well, what we've done is we've set up some typical if, then, else clauses into our rule set to adjust for the fact that not every situation is going to have that magical data combination. We may not have a vector center line for the corridor or overlaying our power line. So what do we do then? Well, there are several options in terms of identifying power line eCognition. We can use various classification methods. We can use deep learning, something we've done in the past as well. In this case, what we're running is saying if there's no existing shapefile here, then we're running an automated point cloud classification algorithm within eCognition, and we can classify the power line points themselves and identify them as power line. We can then use that information as the input to calculate this corridor or ROI region of interest on. But what I'm saying here with these if then else clauses is if I do have an existing vector layer, then I don't have to calculate all this automated point cloud classification to determine where my power line is. I know where it is, so I can just simply set that up. I'm using a variable here with a binary input, one being if there's a vector file available, and if that is true, we will then run in through this block of commands. So yes, this was true. I'm then running a vector buffer algorithm within eCognition. I'm creating this buffer around my corridor based on my user-defined input on what the feeder corridor width should be. I believe in this particular scenario, I ran with something like 100 meters or 100 feet. I'm then going to do a vector dissolve. I'm then going to take these vector objects that I've created, and I'm going to run a vector-based segmentation. So I'm now converting these objects, these vector objects, to image objects within my project. And all this is simply to reduce the amount of data that I'm pushing through my processing. So I'm going to say I'm only in points within this right-of-way. So that's one of the first steps we took here. And we generated our buffer, and we created some temporary point clouds within eCognition. The next step is that we're going to transfer this into an overview map. Within this, we then run some analyses really geared at creating temporary point clouds for the various individual classes. I can see those here. So I've created some temporary point clouds now. I'll turn off the primary input, and we've created a point cloud that just isolates our vegetation points. This is based in part off of the automated classification, and then the combination of that with the right-of-way that we've capped here. So I've done this, I've created several independent temporary point clouds within eCognition, one with my points that are associated with vegetation, one for the points that are associated with the power line itself, and then a third that is just the stripped away ground points. So those last returns that we're getting from LiDAR. And that's what these independent point cloud files look like here within the viewer. The next step that I really run here is we're breaking this whole piece down into subsets. So for efficient processing within this project, I'm going to create some subsets. I define cell sizes to run within each subset. And then we do here, as you can see, we do some rasterization of the point clouds and perform these analyses on each subset primary goal here really to take some of those individual point clouds. For example, we have a point cloud with the ground points. We're rasterizing it, and we're going to do some gap filling there, so we get a nice clean ground layer, so a nice clean DSM, DTM type information from this. What we also do is we're going to run some cleanup, and we're really going to filter out any points from these point clouds and reduce the amount of this, really streamlining our data to improve the handling. Again, this rule set is looking at a production workflow, so we want to have this be as fast as possible. And by doing that, we can take our data, we can massage it, we can strip away some of the points that are just not needed in this particular environment. And that's what this pre-processing step is doing. We're taking this, we're calculating the important information, and we're getting this ready then for the next step, which is the analysis. And I have not run this. This analysis, as you can see in my note, runs quickly, and that's the whole goal. We're doing these pre-processing steps ahead of time so that the real analysis can run quickly, and we can adjust that as needed. So this will be then the actual processing that we do here. Michael, before I run any farther, are there questions that have come up?
Yeah, just a quick question about can eCognition work with any LAS file?
That's a great question. Yes, eCognition, it can work with point cloud data as long as it's an LAS or LAZ format. So if you make sure your data is coming in that format, it can be loaded into eCognition, and you can use it as I'm here. Yes.
Well, and a couple more questions, but can probably wait till the end if you want to keep going.
Sure. If you wanted to throw one more at me now, we can do that. And
yeah, this might be for Cliff. Question is it possible to detect water content in the atmosphere at different altitudes with this YellowScan?
I know what they're asking, and no, I don't think that the frequency of this particular system is tuned properly for atmospheric monitoring. There's obviously some systems out there, both from a wind perspective and an atmospheric moisture, but this one wouldn't be an appropriate one.
Okay, and then kind of a follow-up to that one, there was a slide that mentions a LiDAR working in all weather. So just kind of to confirm, is it safe to work on rainy days and in the cold weather, especially in Canada, from the question?
Yeah, so rainy days are a challenge right now, just simply because we haven't properly gone through all of the, the moisture resistance procedures that you'd want to do. A lot of the, to be honest, a lot of the UAV platforms that we're flying on are as, or maybe even at times more sensitive to certain types of weather events in the moisture side of things. I'll tell you, as far as cold is concerned, though, we've flown these systems at in Colorado, actually, at 11,000 feet above sea level and as low as -5 Fahrenheit. So we've done a fairly good amount of testing on cold weather, and we haven't had any problems with that.
Good. And Keith, there's a question about, is this viewer, which I'm guessing they're talking about eCognition, does it come with the LiDAR equipment? I guess maybe the question is, there a package with eCognition and YellowScan?
No, so the Trimble eCognition software is a separate package. It's not being sold in combination with YellowScan products, at least not at the moment. So if you're coming as a YellowScan customer or anybody else flying a UAV LiDAR or LiDAR in general, or maybe using any type of imagery data, eCognition can be purchased and used to do the processing of this. It's not coming with a specific hardware unit currently. So if there's no more, we'll jump back in now to actually running this find risky vegetation detection. So we've done the pre-processing, we've calculated the as you can see here, if anybody's familiar, we've actually generated image objects now. Remember, we were using limits of this corridor. So we can see that the image objects are also restricted to being within this corridor. One of the other benefits, though, of reducing the data, like I mentioned before, so I said we created independent point clouds within eCognition, so just deriving, taking those points out of the initial point cloud called LiDAR, and created these temporary point clouds, which I've noted here with temp PC veg, as temp point cloud vegetation. And for this, we've run a segmentation, and we've created image objects. So if I turn them on here in blue, we can zoom in and we can take a look at these image objects, get a feel for what they look like at this point. If we look at the LiDAR in the background, it looks a little scat, much correlation, but this is based on some of the rasterized products from the LiDAR that we did in the background. So remember, image objects have to be created, like the name says, based on an image on a raster file. So that's what we've done here. It's a chessboard segmentation. It's going on very quick in the background, and we have these image objects for various vegetation objects here. And now what we want to do is classify these image objects. And I mentioned before in that diagram, we are looking at a class description that corresponds to those various parameters that have been defined by industry. And you can see now in my image object information that I have these parameters set here. So we see this crossing offset, this corridor feeder width, we see this min below distance, and we see this proactive fault clearance. So those again tie into the description, those mathematical formulas that we use to calculate those. And these parameters we will use then as variables for our class description. Why do we want to use variables here? You see these are scene variables. Well, it gives us a lot of flexibility, especially in a production-oriented rule set. First of all, the user at the very beginning, at the outset of a rule set, can go in, and as we can see here, we have this default user parameters for development, and users can set various variables here. So you can see here's my maximum distance to vegetation, to power line distance. This is what I was using to define my corridor. I set this to 100 meters. And what this does is I can plug in to all different types of algorithms within eCognition rather than a fixed value. So I'll open up this assign class algorithm here, and you can see if anybody's familiar with the assign class, you'll say, well, gee, in the condition, there's no value being listed here. What's going on here? How is he classifying this neighboring forest class? So I can open up the condition here, and again, it seems a little cryptic given the abbreviations we're using for the variables. But what we see is we're using variables here and mathematical formulas within the variables. So we can use that for our class description. And we'll run this piece here, should go through pretty quickly. And now we will assign classes to the point, or not to the point cloud yet, but to the image objects, and let this run. The final step while this is running, preparing the deliverables. And this is simply taking the classifications here, so these 4 risk classes, and we're going to take those classifications, and then we're going to associate those with the point cloud. So we will take the classification, we'll classify the point cloud itself based on these 4 risk classes, and then the final step is in taking the vectors, and we're generating vector data sets that can then be loaded into GIS that contain all various types of parameters that we might want to use, so various attributes and feature information coming out of eCognition that could be useful down the road in any type of GIS analysis that's going on. So as this runs, Michael, any questions come in the meantime?
Yeah, we do have one on were the power line vectors provided from an external import or derived from the point cloud analysis?
Right, so that's what those two was what I mentioned earlier was with this if-then clause, if-then-else clauses. So there are two options. The user has the option to bring in an external shape file so for the vector line, or they can use the automatic point cloud classification results in eCognition to identify the power line points and derive their buffer from those results. So this rule set is say savvy enough in this production grade to address both cases. If the the third-party shapefile, let's say, is there, then it will use the shapefile. If it's not there, we can it's smart enough to recognize this and use the results of the automatic point cloud classification. So I've classified my image objects now. You see I have image objects classified as power line here, as well as these various classes. We can see the corresponding class hierarchy type of legend here on the right. So I've identified here just vegetation that's outside the corridor. I've identified tree crowns that are outside the corridor but high enough to pose a risk. We see in the blue here the underlying vegetation, and in the yellow, so this proactive fault clearance, and then some light blue point classes for this branch removal type class. That's wonderful. It looks all nice here in this view, but now we want to get into our actual deliverables. So we'll come down, and one more thing we're going to do is classify the point cloud. We'll run this, and we'll take a look at these deliverables in just a moment. And then we're just going to remove some outlier points from the classification. And finally, we run this 3D vector generation. So taking the results of these image objects, converting them into then vector files, shape files that we can then output for use outside of eCognition. And as this runs, we can take another question, Michael.
Yeah, another question about the analysis you're doing within eCognition. Is that just using the standard tools, or is there a specific like vegetation analysis tool that you're using?
Yeah, so I like to think of eCognition Developer as a large toolbox for not only image analysis, obviously here in this case, pure point cloud analysis. What we're doing here is we're using standard tools available within Developer. All the tools that I'm using in my rule set, obviously I've assembled them to create this rule set, but these are available to every eCognition user. And there's nothing, third party brought in here. There's nothing extremely secretive and fancy that's sort of our IP. This rule set is using my skills as a developer to assemble the rule set. So I'll just run these last pieces here. We've classified our point cloud and remove just the last little sections here and create our vector files. And then we can take a look at this in the 3D viewer to get a sense of what's really gone on here. So just let this run for a few moments. And we can also take more questions, Michael, just as these algorithms go.
Is chessboard the only segmentation that was used for the objects in this rule set?
I believe we use a combination of chessboard segmentations. We had the vector-based segmentation earlier in the rule set, and we were also looking at multi-threshold segmentation. So 3 different segmentation algorithms were used during this rule set, and some of you out there might be scratching your heads. Wow, gee, why didn't you use the glorious multi-resolution segmentation algorithm? That's the one that all eCognition users are familiar with, and I guess we become famous for? Well, it's because it doesn't always fit within each analysis, and there are lots of other algorithms that we can use, and lots of other algorithms that are faster than a multi-resolution segmentation algorithm. So these approaches have given great results and have also a flexibility in the speed that was nice for particular analysis, because again, we're thinking production, we're thinking going beyond just small snippets of data, taking this for entire sections of transmission line here. And as this last piece runs, we will then turn on the vector layers and we can see what this looks like. And this will hopefully be done in just a few moments. Apologize that we've taken up our hour here, but if you have some time, just stick with us a little bit longer. We have some other nice surprises up our sleeve here in the next 15 minutes or so that would love to show. If you have to leave early, I apologize that we've run over, but note the webinar is going to be, it's always recorded and it'll be available, and you can come and catch up on what you missed in the recording. So I've run this now. We have our vector results, and we'll take a look at these now in the 3D viewer and get a sense of what are the deliverables that we've actually created here within eCognition. So turn off our classification view first of all, zoom out a little bit, and we can turn off this full point cloud. I'm just going to take a look at the one called temp PC vegetation, just represents my points in vegetation. You see I'm still in height. I can now turn on a classification view. So I've classified these points now, and now I can visualize this classification. Could be nice just to match the classification colors here. We can do that quite easily with what we have in our class hierarchy, and then everything matches nicely in terms of visualization. So 17 was this right here, and finally. So here we go. Now our color scheme should match up, and I can come down with the 3D subset selection tool and actually get a sense of what this result looks like. I'm just creating a 3D subset here within eCognition, so I can examine my results in 3D 2.5D as you want to define them.
Heath, you have some of the trees that are green, and then some of them have that kind of purple in the center. What's the difference between that color scheme?
So we have this, so a tree, say up here where my mouse is located. So these are trees that are located outside the corridor, but are still at a height where they could pose a risk in falling and touching the transmission line. That's what this sort of this cyan purpley color is. So we can look at this here. You might be wondering, well, where is these trees over here aren't too close. What we actually have here though is, I'm going to turn on the point cloud for power lines and add this to our view. There are several transmissions, and when you actually look at this data set, there's a road that runs down the center of this area, and there's a smaller line on one side of the road, and then the larger, higher line. Excuse my lack of professional terminology, and I'm not from the power industry. But here we can see the results. We've classified these. Our points are available in 3D. Finally, I said we created vector files. I can see that these vector files are available over on the left-hand side here in my view settings dialog. I can come in and turn these on, and we'll take a look at them here in the viewer. So we have then the vectors colored in according to the, also sorry, I have to adjust the class here. So this was our class colors, and then these vectors will match the color scheme that we have here. Maybe become a little difficult to see within the point cloud. So we'll zoom in. Take a look at this, and just to show we do have actual 3D vectors, we can turn off that point cloud and then see our results here. So these vectors reflect the elevation of the objects that they contain. Finally, what type of information do we have here? So we can open up our thematic attribute table, and I will just pin off these other windows. And we can examine, oops, the information here. So we have all sorts of attributes or in eCognition features that we can store in this file. We have all of the various distance attributes, the elevation max, min for each objects. We have various quantile elevations that we've decided to store. We have the number of points. And another one that I've chosen to calculate here is the cut volume for an object. So if I select an object here in the viewer, I'm actually going to jump down and I can see this object in the thematic attribute table here, and I can get a sense of this, of the volume that we've just mathematically calculated here. I believe this is in the cubic feet, if I'm correct in my calculation. So the volume in feet for a particular object here. And I can jump through this table, clicking on the various objects and jump to that to get a sense of what's going on. So that is this corridor feeder analysis. It's run completely automatically. There's no manual touches other than me actually physically clicking in the rule set A to adjust, maybe adjust the initial parameters for the variables, or clicking execute. If we had eCognition server, we could have just sent this all off to a nice server environment without really interacting within the eCognition project. Before I move on to the final part of what we wanted to present today, Michael, in terms of what we can extract from LiDAR data, in this case, this UAV-based LiDAR data, are there any questions to what's gone on right now?
Just more quick one, because I think you broke up when you were talking about how these tools in eCognition are available. Are they only available in developer in that?
Yep, so this rule set was created in eCognition Developer. Developer is our rule set creation platform, if you will. So if you want to work with point clouds, you'll have to have eCognition Developer. And if you want to work with any type of an analysis like this on the point cloud, the tools are available within eCognition Developer.
And are these specific rule sets that you created, are those available to download or to purchase somehow? Or?
This particular rule set isn't available online in, say, the eCognition community. It's one that we've been developing in-house, but like I said, all the tools that are used here, there's no secrets, there's nothing customized from our team. These are all using standardized tools within eCognition Developer. And we can certainly, if people are interested in the rule set itself or how this could be used on their data, they should certainly reach out to us, and we would be happy to exchange knowledge in some form or another. So the final thing I wanted to show today, I said we were going to try and push the envelope with LiDAR data. Maybe some of you are thinking, wow, gee, what could you do more than that? And then classifying the point cloud, extracting 3D vector files for the objects. Well, this is some pilot work, project work we've been doing internally, looking at point cloud data, what's possible within point cloud data. So again, I've got a YellowScan data set. I believe, Cliff, this is the one that was flown in Colorado or Utah. We see a transmission line here, or a distribution line. And what I want to do from this line is, at this point, I want to extract 3D vectors of the line itself. So if I come down here and just draw a small view box, 3D view box around this section, we can see what my goal is for this analysis. So when I look at this in 3D now, I see these 4 independent lines, and what I would like to have is a vector line that corresponds to each one of these lines as they are here. So that's what we're going to do here. This is what we call, say, you might want to call it a point and classify, or a semi-automated user interaction-based rule set. Also a nice thing that can be created within eCognition. And while this is closing, I should mention again, this is all specific tools for eCognition developer. So the first thing I want to do, I'm just going to set some parameters, and I am then going to set what is called select a baseline, and I'm going to define just what direction do I want. I'm going to be doing line extraction here. I'm going to just give eCognition a general vicinity of where this line is. I don't have to get too caught up in the specifics, so I'm creating a line here just perpendicular to the transmission line first of all, and then I'm going to drop a line, just a point up here. So I just have to drop 3 points. eCognition then draws 3 lines here. We can take a look at these. These are vector files within eCognition. You can see I'm not right on top of my transmission line here. Should still work. So I'm just setting the general direction. Where are the points that I'm going to be looking at? What general vicinity am I in? The next thing I'm going to do is I'm going to set some key points that are going to be used to create templates from our point cloud. So I will come down, execute this, and then as a user, this is where I have to physically interact and create, just drop the 3 points. So will be entered into this 3D viewer section here, and I'm getting a cross section of this transmission line. So that's where those select baselines, that's where this comes into play. And I can see just some groups of points here. If you follow my cursor, these 4 little groupings of points, those clusters are the points around each one of those 4 independent lines. So I'll just drop a point roughly on each one of the clusters. And this is now where I'm going to establish my template. So we're using a template matching technique here within this rule set. Let this set sort of finalize these key points, as we've called them. And the final set now, I'm actually going to apply this template. Just zoom out a bit. So we can see those vector files here, those little crosshairs, those are where my templates are located currently. And now, using the information that I have stored in my baseline, I'm going to step down this line with my templates. And in this case, these 4 templates 1, 2, 3, and 4. And we're going to use these to create a 3D vector line. And what I'm going to do here, you see this 5x or 5 times do. What this means is I'm just going to simply run this 5 times. And as it's run, it's going to take this template. We're going to walk down the transmission line, if you will, and we're going to apply this template to look at how the template fits with the data. And as you can see, we've dropped 3 points already here in the viewer. There goes the 4th point. And you can watch this progress live in this particular demonstration we'll set here. And then we're going to connect these points with line information. And that's now run. Turn off the points themselves. And we will now come in, again, using our 3D tool here. Just take this section of line where we let this run. And we'll take a look at these lines now in 3D. So again, nothing to see here. I haven't turned on the vector lines, so we can do that in the viewer. And now you can start to see this vector, these 4 vector lines appear here. I'll turn off the point cloud so we can see these better. And I can take these lines, I'm turning them within the viewer. I'll turn this back on, reduce the point size here. We can see those lines, those vector lines. So this is something we've been working on internally, really just extracting line feature type information from point clouds. One of the experiments that we wanted to see was whether a UAV-based LiDAR sensor like YellowScan would support this rule set in running. This is something that up until now we'd run on some of the Trimble total station devices that we had, so different type of point density and collection method. So it was really great to see YellowScan data also cooperate in this type of environment to create these types of results. So this was for us a nice success story, seeing that what we do in one area can also transfer to another with eCognition and really pushing what we've done with our software. So that brings my presentation to an end here. I'm just going to bring up the slide deck again. And at this point, if we have some questions, we can certainly field them. I think we can take another few minutes to do this, Michael, and before we close down for at least my evening time here.
Yeah, Cliff, we had one for you on the YellowScan cloud station. Is that run exclusively online, or is there kind of like a standalone version that you can use? And the question is really around for large data set processing.
Yeah, right now at this point in time, Cloud Station is a locally installed application, so we're not to the point where we're moving into that cloud-based processing.
Sounds good. And I guess for Keith and Cliff both, there's a lot of questions on, people are looking to get kind of this solution, the software and the hardware. What are the best ways to go about to kind of start that process of, looking into if this is the right solution for a certain organization?
Keith, if you don't mind, I'd like to jump in on that one real quick.
Sure, go ahead.
Although there's certainly no, I guess I'd say, global arrangement or partnership between Trimble and YellowScan at this point in time, individual local dealers at the Trimble level are in various degrees starting to show interest in the LiDAR products at YellowScan. We've signed up across the globe, several, probably on the order of 10 or 12 different dealers so far. So, it might be the best that you just check with the local dealer, see if they're already in the process of representing the YellowScan product. If not, let them know you're interested. Have them call me or you call me, and I'll talk to them, and we'll see if we can get something worked out.
I think Cliff fielded that one exactly. So there's again no official partnership between Trimble and YellowScan, but I think the local dealers are the best point of contact in terms of both products. And if you're on our eCognition website, you can certainly, that's www.ecognition.com, you can certainly fill out the contact sales form there, and then the sales representative will contact you regarding the eCognition software. In addition, I know there's a questionnaire at the end of this this webinar. If you have interest, please fill that out, and we'll definitely reach out to you.
And Cliff, a question on the GNSS or GPS sensors used with the YellowScan system. Are there certain types you can use, or are there multiple versions of the GPS unit you can use with that?
I'm assuming you're talking about the base station receiver that you would use to collect your corrections signal. Assuming that's the case, then yeah, there's a variety. You just need to be able to provide a RINEX file to the POSPAC solution, and there's certainly Trimble products out there, but there's others if you're already invested in other products.
Sounds good. And Keith, a question for you. I guess the question is, would it be possible to deploy a portal-based tool to create this type of data? I guess if you use developer, server, and architect, is there a way to kind of create some sort of portal that users could log in and kind of do this analysis?
Yes, definitely a possibility. We actually have a dealer, our local dealer in Germany, Tama Group, who has created a portal for forestry type applications. It's available now through their website, where they have, I believe I wasn't involved in actually creating the product itself, but there are some eCognition engines, so server engines, kind of working behind the scenes to do analysis to a certain extent. What portals will look like will depend on your needs. You can combine, they can be combined with, I'd say, probably server and architect type applications would be the best fit for this. Whether it's something that's going to be hosted in the cloud, and it's something you're gonna have to think about your data, pushing data back and forth, what type of requirements and restrictions are out there.
That's good. You guys both kind of covered, how to maybe go about purchasing this, but there's a lot of questions that have come in about if someone isn't ready to bring this in-house. Is there a way to, leverage this as a service, both from the, the LiDAR side and from the eCognition side? Are there people out there that provide these services for the solution?
Well, from the data acquisition side, I would say that depending on which region globally you're talking about, there's certainly a growing capability within the service markets. In the U.S. market, I'll say it's been quite matured at this point, and I would say there's definitely many different folks you could reach out to, and what type of back office product flow that they provide is, I guess, the what you'd have to look into.
Sounds good. And then Keith, maybe one last question for you.
Mm-hmm.
You could probably wrap up. And I'm not sure if you'd cover this, but in terms of automating this workflow, I guess if someone flies this data every month or every 6 months or every year, is this something once you set it up, you can just reload in that data and, you know, just kind of processes and updates, you know, your analysis.
Yes, yes, absolutely. So the rule set is established. It's working. The development time was put in to create it, so it works on universal. And I've done, so you know, I've executed this rule set, YellowScan data, but other LiDAR sources, not just UAV-based LiDAR, but aerial LiDAR data, and it also functions quite well. So you can take this rule set, and when you fly new portions of line or you refly your corridor, whether it's on some type of regular basis, every time you come in, you can start submitting these jobs, run them through the rule set, and you'll get a new set of results that you can use again and again. So it's fully automated. It's designed to wonderfully to work within an eCognition server environment, so you can really push through big chunks of data, full in batch processing mode, and just walk away for, let's say, the weekend, and come back on Monday morning and start jumping right into the results. So it's not just for specific data set that we looked at today, or not just for YellowScan specific LiDAR products. It can handle the point clouds. Is one thing you may want to consider if you're working with some very old LiDAR data, whether the point cloud density is good in certain spots specifically for that, the automated classification of the power line itself. Sometimes it's in some of the say the older generation LiDAR, it's not as well suited for that detailed of a classification, but that's why we integrated in the piece on option for using a vector data file as well. And if that wraps up our questions, if we didn't get to your questions, first of all, I apologize. Again, I apologize for running a bit over today, but it was fun and we had a lot of cool stuff to show. If we didn't get to your question, don't worry. We always go through those the question results. We have that information, and we will reach out to you afterwards. At this point, I'd like to say thank you for your time today. Again, my name is Keith Peterson. I'm the product manager for Trimble eCognition software. And I think the best way to follow up with us is, again, if you're looking for sales related information, you can use the contact sales form on our website. Or if you have questions that didn't get answered or looking for more information, you can always reach out to support@ecognition.com. This is the best way to get a hold of one of our support engineers in the timeliest of manners. And Cliff Holle's information is here as well. Cliff, do you have any other closing remarks that you'd like to put in?
No, I just appreciate everyone's time. I know that everyone's busy these days, and thank you for taking such a big chunk out of your time to be involved. This was a really great presentation, and I appreciate being asked to be involved. Thank you.
All right, that being said, thank you again, and we will sign off. I hope to see you next month in our next eCognition webinar. Topic is to be determined at the moment, but I hope you enjoyed this one, and see you next time. Bye.